So students, how are you doing first? Well, okay. So, we have been discussing the chapter circular motion. Now we are going to start with the next interesting module. Now what is this module? Yes students, this module is about uniform circular motion. Now students, we have seen what is a circular motion. But in this module, we are going to define a very special type of circular motion called as uniform circular motion. Is that clear? It's a very important module. So, are you ready? Can I start with the module? Alright, fine. First, what we are going to do? Yes, we have to define what is uniform circular motion. For this, I am considering a particle. Now, this particle is performing a circular motion. Now, hold on. Rather than saying this particle is performing a circular motion, I am saying this particle is performing a uniform circular motion. Alright. Now, you might be thinking, what is this? Sir is saying uniform. What is uniform circular motion? Very simple, students. A particle is said to perform uniform circular motion if it moves in a circle or circular arc under one important condition. What condition? See there. At a constant linear speed or constant angular velocity. So if this particle is going to move in a circle at a constant linear speed or constant angular velocity, then this particle is performing, yes, a uniform circular motion. Is that clear? So these two words are very important. Constant linear speed or constant angular velocity. And you all know what is linear speed. Yes, linear speed is magnitude of linear velocity. So the linear speed should be constant or the angular velocity should be constant. Now did you understand what is UCM? Fine. Now one important point is there about this UCM. What is that? See here. In a uniform circular motion, a particle covers equal distances in equal intervals of time. Why? Because it is going to have a constant linear speed or constant angular velocity. So, the particle will cover equal distances in equal intervals of time. Is that clear? So, this point is very important. Now, based on this, I can give one more important point. What is that? See here. In a uniform circular motion, the particle takes the same time to complete each revolution. Why? Again, constant linear speed or constant linear velocity. So it is going to cover equal distance in equal time. So the particle should take the same time to complete each revolution. Is that clear? So students, this is very, very important. Definition of UCM and these 2 points. Alright, equal distances in equal intervals of time and the particle will take the same time to complete each revolution. Is that clear? Fine. Now students, I'm going to explain it to you more about this UCM, uniform circular motion. For that, let me bring in one more type of motion. This is called periodic motion. Have you heard this name before? No? Periodic motion. Can you guess what is this periodic motion? Yes? Very good. Something about time period. Nice. Now students, periodic motion means any motion which repeats itself at equal intervals of time, then such a motion is called as periodic motion. Example, very simple. Can you give any example? Yes? Very good. You see here, the revolution of the earth around the sun is a periodic motion. Yes or no? It repeats itself at equal intervals of time. So this is a periodic motion. Any other example? No? What about this? You see here, what is this? It's a simple pendulum. Yes or no? The bob of the simple pendulum performs a periodic motion. Provided, again I am saying, provided if you neglect the air resistance, the damping force, then the bob of the simple pendulum performs a periodic motion. It repeats itself at equal intervals of time. So did you understand what is periodic motion? Fine. Now why did I bring in periodic motion? I will tell you. You see this on your screen? What is this? Yes, it's a clock. Now you notice that seconds hand of the clock. Which is your seconds hand? Yes, that red color one. Now the tip of the seconds hand, it will move in a circle. The seconds hand is going to sweep a circle and the tip of the seconds hand will move in a circle. Alright, now the tip of the seconds hand is performing a circular motion. What type of circular motion? The tip of the seconds hand is performing a uniform circular motion. Why? Because it will cover equal distance at equal intervals of time. Alright, its linear velocity as well as angular velocity will be same. So the tip of the seconds hand is performing UCM, and in UCM, the particle takes the same time to complete each revolution. And what is the distance traveled by the particle in one revolution? It is equal to circumference of the circle. So since the particle is taking the same time to complete each revolution, we can say that UCM is a periodic motion. That means it is going to repeat after equal intervals of time. So UCM is a periodic motion. So Earth, revolution of Earth around the sun is also periodic as well as it is UCM. Is that clear? But don't bring in that oscillation part. Is that clear? You will be learning in detail about that in oscillations chapter. So is this clear, students? What is UCM and how UCM is a periodic motion? So it's very simple. Remember this. I'll catch you up in the next module, students. Until then, keep working, students. You can do it. Rise and shine.